to have a simple policy-based control on uh, control operations of the cluster, which is basically create and update. So that's where the basic use cases include mission and audit, which means that any create and update operations have certain policies, and those policies should be easily managed on the cluster and across clusters. The second scenario was audit, which is that for the current state of the cluster, what are the policies, what is the state of every object in regard to the current policies of the cluster. So those were the two basic things. So let me go through the personas basically. So there are essentially two classes of personas, one being the administrator of the cluster. These administrators can actually be multiple admins. For example, network admin or security admin or different kinds of admins, right? And then there's the user of the cluster. So in the diagram, in the components, it basically shows the flow of how it works. So the admin comes and installs policies on the Kubernetes cluster. And once the policies are deployed, the other admin, which audits, the auditor, you can say, audits the cluster for the current state of the cluster regard to the current policies. And if there are violations, there's an external mechanism of resolving that violation. That's out of scope of how the violation is resolved, but it kind of gives the telemetry and information of what policies are not working. So from the user perspective, the user does a create or update operation on against the Kubernetes API server. So the green arrows, if you follow, goes to the Kubernetes policy is deployed, controller is deployed as a service, which then redirects it to the correct pod of the controller. Within the controller, there are essentially three pieces. One is the admission piece that talks to OPA. So all these policies that were created are stored in part of the memory of the Open Policy Agent server. And the Kubernetes policy controller uses the query endpoint to query the policies and uses the data as format of the query. And when there's an admission, there's also audit case where the audit endpoint exposes the current state of the audit cluster. Are there any questions? Okay, so very recently, folks from Dellner, Mercedes-Benz added a third use case, which is the authorization use case, which is that RBAC doesn't always support all the cases. It requires more detailed policy level support. So now the Kubernetes policy controller also supports authorization module, which basically does the authorization for all the requests sent to API server. So going down, so as I described the high level components, the policy is basically has a template. So one of the example policies, if you would write, you would never write this policy, but basically it says deny everything policy. So normally you will write some logic in this policy to kind of encapsulate your policy, but this kind of describes a template. So there's a package admission which you'll use to define the policy, and it will have three essential parameters. One is the ID, which recognizes the policy uniquely in the system. The second is which resource filter do you want to apply the policy on. And the third one is the resolution, which is, so essentially there are, from an admission case, there are two basic resolutions you can have. One is one being the validation webhook and the mutation webhook. So the resolution can either be a message or it could be a set of patches that you want to apply on an object, which you'll send back to the API server. Example where which provides the image pull policy, setting the image pull policy is always on any basically pod that is being created on the cluster or any container on the cluster. You're setting the always flag. That's the very high level, and then there's the authorization piece of it. Let me go to the demo. Are you guys interested in a demo?
Sure.
Okay. So I have this Kubernetes cluster running on Azure. It could be any cluster, really. And so let me demonstrate an audit case. So what I have is in the OPA namespace, I have the this pod running, which has 3 containers. Let's see. So it has you see the container that is the open policy agent, and then there is the other container for the policy controller and the cube management. There are essentially 3 of these containers in the system. And so first case is that we haven't deployed any specific policies, and we want to look at the current audits. I'm just port forwarding to the pod so that I can query the audit endpoint. So if you see currently the cluster, it says 0 violations, violation being violation of a policy. So all the objects in the cluster are meeting the policy, which since we have no policy deployed. Now what I'll do is I'll deploy a pod. So I have a bad ingress bad example. So since there's no policy defined, there's a bad ingress that we created. And now so at this point, imagine this cluster is an old cluster, and the organization decides to deploy certain policies on the cluster. So we will go ahead and have a script which will deploy the policies. Deploy admission policies. So it deploys this ingress source FQDN policy, and at this point I want to see what is my current state of the cluster. Does it meet all the policies? I created a new policy. Does it meet all the policy requirements? So I audit the cluster. So I see that I have one, since I just deployed this ingress bad. So I'm violating the FQDN definition for the namespace. So at this request, so imagine there's a service that is auditing this endpoint, and it gets a message saying, hey, you have a policy that is violating. So this kind of describes the audit case. So what will I do here, right? So imagine the resolution is that I actually go to this namespace and see this ingress controller. It has, I cannot use acmecorp.com, right? So I go and delete this ingress. All right, so I deleted this ingress, and immediately I should be able to audit the current state of the cluster and see that, yeah, I don't have any more violations because I removed the violation from my cluster. So this is like absolutely real-time audit case for your cluster. And so from now on, if I try to deploy my bad ingress, I should not be able to because I have applied the policy. So if I try to deploy this again, actually, this one, did I deploy this guy? Yeah. Let's see. So this kind of describe the scenario for the audit. Yeah, do you have any questions?
Yeah, I have a couple questions.
Yeah.
One, the choice to use a config map over a custom resource. Was there a reason for that?
No. So this is work in progress.
Okay.
So as you see in the design, this is a policy as a CRD. So there is a group of people, community working on the CRD part of things still to come. We have folks from Google who are working on this. We're kind of collaborating on this project. And the plan is to move this project to, I mean, we're still considering it's not final, but either to Kubernetes repo organization or to OPA organization. So there is a bunch of features that are going to kind of come in through. So this will be CRDs to answer your question.
Okay, cool. Do you plan to make those namespaced or?
Yeah, so there is a design that we will publish around CRDs, but the idea here being that, as I mentioned, there's not a single admin. There can be multiple administrators. And the way we will define policy is so that each CRD type will basically could be managed by a different admin profile and can have RBAC on it or things like that. So yeah, you can deploy any policy to any namespace. So it doesn't matter which namespace. You will have to kind of annotate it that it's a policy. Or once we have CRDs, it will be a type that the system will recognize.
I'm a little also confused about the relationship between your OPA server that's running, the policies that are stored there versus the policies in your cluster.
So all the policies that are actually part of are stored in the policy server. So the state of Opus has a runtime state. The storage layer being Kubernetes etcd in this case. So it's kind of syncing against the current state of the cluster. So it's like any other object in Kubernetes, right? So you create the object, and your pod is basically has a eventual consistency with the current state of the cluster.
Okay, so the only backing data storage for the policies is the Kubernetes resources.
that what is behind the specific? I just want to make sure I answer your specific concern.
Are there, so you have a, where are the policies are stored in the config maps to be custom resources? Are there other policies stored in a different place?
Right. So it's an excellent question. So so what we are envisioning is that there'll be a library of these policies that will be either available on GitHub as a repo, and which will be have certain specific releases and can be consumed by users. And then how each individual organization consumes is kind of out of scope of this specific controller project. But from the ecosystem perspective, it makes total sense to have a delivery mechanism to the cluster to think about that kind of a scenario. How those policies get delivered to the cluster? How does the version control happen? How, like, those kind of questions. But specifically to for the policy controller, it is agnostic to the contents. It just acts against what it sees and what it's running, and it will. So the pieces that it has within is that it basically validates individual policies. So the policy controller will have validation logic to make sure that each policy compiles, for example, or each policy works well. So there's another scenario that is in progress, work in progress, is that I'm, as an admin, I have a new policy, but I want to make sure that I'm not going to break the entire cluster after I deploy the policy. How do I do that? How do I validate that? What is the effect of my policy on the cluster? So there is work in progress to basically use the current state of the cluster to validate the policy. Does it ring a bell? So basically, I have a new policy and I want to test it or validate that policy and get an audit report for it as if it was part of the cluster.
Right.
Right. And then you can even play the old requests that were coming into the Kubernetes cluster and things like that. Does that answer your question?
Yeah, I think so.
Okay.
Yeah.
Sure.
Another question I had was on the mutation and the patches.
Right.
I'm always really weary of that because it makes it very difficult to trace what's going on.
Trace in the sense audit?
In the sense of, if you're a user and you're like, why does this keep changing? I kept specifying something else.
Mm-hmm.
Or why is it getting, why is this thing happening? It can be,
So it can be difficult. So I see your point. What you're saying is that I am a user of the cluster. I am not aware of any of the policies that are part of the organization because I don't really know. That's not my job. But if something is blocked or modified, how does the user know what the policies are? Right? Why? Like, kind of say, why did it happen? Kind of thing.
Mm-hmm.
This is a good point. I think there are audit reports that we are planning to expose from the Kubernetes audit reports of saying why was this kind of done is an interesting thing to expose an endpoint on the cluster to answer why for the policy. To say, hey, this patch was applied on this object. And so actually the Kubernetes policy controller returns the result back to the API server. But from users' perspective, they wouldn't know unless they go and dig into the audit endpoint, right? like they basically,
which they probably might not have permission to do.
which they won't have permission to do. So I think this is a general high level, like how does mutation, work on Kubernetes, right?
Right.
So, but I think if the policies are constructed in a fashion that is well understood by the user, I mean, it's easy to say that way, but I see your point that, it's a problem for to answer on how can the user kind of know for the actions they did, what actions API server took.
Yeah.
I mean, there are so many other things that the API server does that maybe.
Oh yeah, this is not a problem limited to this.
Yeah, what I'm saying is maybe any webhook can provide like endpoint of reasons can be exposed if there was an external webhook making a decision or things like that as part of the creation message or things like that, maybe. So there's something I can explore to think about, and we can create a issue to kind of think about this as well. I think it's a very valid point of how does a user know what the hell is going on in the cluster?
Yeah.
That's basically it, right? It's a genuine concern, right? Like if I have a pod and suddenly I see a container running in as a sidecar doing like container image vulnerability check, right?
Right.
I suddenly see that, hey, I was just running this stupid container to say hello world. Now I have like another cluster running taking like 10% of my CPU. I don't know, like it'll be surprising, but I guess maybe the Kubernetes policy controller can expose a user readable policy agreement, or like you can kind of query the policy endpoint to say these are the policies on my cluster, this is how I behave, right? Maybe that will kind of documentation might help as well, but it's a meta higher level question of saying how does API server expose this to the user.
Right. Another question I had is thoughts about kind of a multi-tenant situation where you kind of have like admins, cluster admins, and then more project admins. If there were any thought about how to handle that well.
Or will there be like benevolent admins that maliciously audit?
Maliciously audit what?
Audit the policy.
Audit or update?
It's like audit. It's like attack. Would that be possible?
So I think this is so there's an authorization module as well in the in this policy controller. So you can set up like policies to say, hey, any request for admit is only allowed for. You can set whatever policies, right? That's what the authorization module is for.
So would that be like back to Erica's question, like scoped,
yes. So that's why CRDs are there. So we'll have, that's one use case of CRDs, that you can actually scope them down based on type. So you can say this particular user has this type, this policy has this type, and
in kind of going back to the mutation, we have learned in somewhat the hard way that it can be very confusing to sort of have defaulting or mutations in the same step as the validation. I would definitely recommend splitting those out in a more clear manner.
So I have heard different conflicting views on this. Um, Actually, to begin with, this project had separate validation and mutation endpoints.
Mhm.
And the scenario that what we were looking at as is that this webhook can live internal to the cluster, or it could look external to the cluster as well. Or it could live on a network uh, through the public network on a completely different data center, which means that there'll be uh, RTT involved in terms of communication from the API server to the webhook. And if we had these two different webhooks, there'll be two times the RTT time to kind of add to the policy decision. It can still be configured as two separate endpoints if you want to, if it's required. I think it's a good point to say that keep that design of isolating, if required, validating and mutating webhooks separately, right?
Right.
Yeah. So I think we should keep that configurable on the use case, so that it's a kind of a design choice on the organization to select, default being that there's a single, or and then they can separate it out if they want to. But I'm interested to understand what are those cases that you have seen. I Is it the conflicting cases where there are conflicts on objects?
I think mostly it's just kind of how clear it is with people to understand what's happening, and yeah, confusion around the ordering. I could find the exact use cases or places that we've run into problems with it if you'd like. I can't think of
right. So the way the logic of validation and mutation works is actually in execution time, it runs validation first.
Right.
Sorry, it will run mutation first.
Mutation first. Yep.
Yeah. So it will run mutation first, and then it will validate. So that's how it runs it. That's how it works. And if there is a conflict, it will say conflict. Yeah, it cannot do anything about it. So sorry, denied. Yeah. So, but I have thought about this problem, but there can be conflicting cases, and there can be cases where the administrator of the cluster has defined such policies that are conflicting, right? There is scope where we can limit the number of conflicts that happen. Say, for example, there are two policies which are working on the same path of the object, right? So, I mean, that can be figured out at compile time to say that there's already a policy that's working on this path of this specific object, and there's a conflict. Sorry, you cannot debug your policy. I think those are the cases that can be solved offline, but I agree that it's still, there is scope where you can hit yourself on your feet, and get stuck and almost make the cluster unusable, right? That point.
Yeah.
Yeah. That's a problem. But I think this doesn't increase, like having validation and mutation together doesn't really magnify the problem. It still keeps the same problem, doesn't solve it.
Yeah.
But yeah, I am fairly new to this policy area, so I have tried to think about these problems, but I may not have the entire context, but I'll surely looking forward to all the experts in this working group to kind of, review the design, and this is actually the very first attempt. So there have been multiple ideas from different parts of the community, including different implementations. So everybody is interested to kind of collaborate and create a single policy controller.
Mhm.
And like people from Google, there are people from other companies as well. Uh, so I think there's a lot of design reviews that the next step is to kind of make this, move it from Azure repository to OPA or Kubernetes repository, and then welcome like design proposals. And I think we'll kind of together. There's some of the questions you asked around admin, right? Those are the areas where there was good ideas from folks from Google.
Yeah.
And then there's another company working on the validation aspects of things. How do you validate policies?
Mhm.
Yeah. So there'll be updates to this design. Just like I think for good. And then there were questions around why did we keep the policy controller separate, and like why did we not consume open policy agent directly, and why do we use Kubernetes policy controller?
Yeah.
I'm just kind of creating questions here. So in lack of a lot of people. So the reason was that we wanted to have an audit scenario. To be able to audit, you don't want to run against the current state and memory of open policy agent, because it has to evaluate against the uh, real state, not the artificial state. Like if there's a new request that comes in, you want to run it as if it is not in the cluster. It's a new request. So there's an audit scenario there. And the other reason is that we wanted to separate out open policy agent, and so that it can be decoupled from Kubernetes specific implementation, and not kind of polluted with Kubernetes things.
Are there specific non-Kubernetes use cases that you know of that are strongly used? Because like even Istio like uses Kubernetes objects for their policies.
No, so you mean for open policy agent?
Yeah.
Oh yeah, open policy agent is used in several different scenarios by different companies.
So
Not
is there,
specifically Kubernetes. So
is there any scenario besides OPA, other component that can be plugged into the policy controller?
Sorry, I didn't get your question. Was it a comment? Or?
Do we have any scenarios that you have like policy engine or other things that is not OPA but can be plugged into the policy controller?
Oh, so any guy who implement any module that implements this interface, the query interface, can run against this Kubernetes policy controller.
But they have to support the Rego file format, or doesn't matter.
That's fair. I think as long as the query endpoint is very it's not specific to Rego, because it's just passing in Kubernetes objects.
Okay.
But it's a fair point. Maybe the designs. So there was ideas around validating the policy itself. Maybe the validation should be outside the Kubernetes policy controller, so that the controller is not dependent on Rego and anybody can implement a policy agent.
Yeah.
Was that your? Yeah, I think it's a fair design choice. It's just that it makes the number of components more, but I think I mean you can, if we really strive for it, it's possible.
Yeah. Okay.
But it's not there now at the moment.
Okay.
But I think as a policy language, we did explore various things, various options, and there aren't many. at least from what I saw. Maybe you guys know more about.
Yeah, definitely.
Because the the problem with Rego is that it's not user friendly, in my opinion. I mean,
Okay.
lot of folks from uh, uh, OPA may agree or not agree, but like, that's my personal thing, is that writing Rego is hard. Making mistakes with Rego is easy. So the other thing that I tried out a couple of weekends back was, right?
Right.
So what I did was, I can show you something quickly. Is that I created charts, Helm charts.
Mm-hmm.
This is again um, premature, but like so. So basically, I reduced the policy to policy parameters. So this policy says conditional annotation. So you can imagine that the user UI basically is able to read this YAML and provide this matching annotation and target annotation as parameters. So the user or the administrator doesn't really see Rego at all. It's all parameter. So the library will have a parameter file and the Rego file. So, and the Rego file is more for people who are creating Rego files in the library, but for the consumers of the policy, they don't really see the Rego at all. There is another proposal that actually Tim sent out to me just like today, which was, oh no. So we have a Slack channel, by the way, and on the OPA. So he just sent out to me a proposal on how to pass in parameters. So if you guys are interested, you can read through this.
Yeah, I'll do that one. That's going to be interesting.
Yeah. So, but it's still open. Still not, there's a lot of scope to kind of improve on this aspect of how can we make this simple and predictable and testable. Like it's easy for the people to use it on the cluster and they feel safe about it. It's not like, hey, I did something and I'm busted, because it's actually API server, right? So you can easily harm yourself.
Right.
Yeah.
So is there any plan for Azure to use it like in production, or just sponsor the development for the moment?
So a good question. I can answer. There is definitely interest to have this as a product, and for our Azure Kubernetes service offering, to basically allow customers to be able to, but I can't share details, obviously.
Okay, so that'll be part of the AKS.
I mean, it really, any Kubernetes cluster on Azure, right?
Oh yeah.
It doesn't really matter.
Okay.
Yeah. I believe there are other cloud vendors who are also interested to provide similar kind of things for the customer. And after releasing this, I did get a lot of interest, like messages from different parts of the different cloud vendors as well, to collaborate. So I believe what I heard was everybody's working on same kind of scenario. I think there's general customer interest which is driving this kind of scenario, especially because Kubernetes admission controllers have become more first-class citizens in last 1 year or so. that um, general interest to make enterprise customers use Kubernetes. So what we found was enterprise Kubernetes clusters customers were, I mean, one thing that they want is to be able to regulate and control the environment in which the clusters are running, and be able to audit them on periodic basis. So audit, actually, Azure announced Azure Governance. I don't know if you're familiar with that. It's part, so Azure Governance, Azure Governance. Yeah. So basically, we allow, managing any resource, doing the same kind of compliance on your resource. So Kubernetes clusters are another resource for Azure, and so it kind of makes sense for us to support that.
Cool.
All right.
Great. So I haven't really learned what you guys do.
Yeah, I think we're out of time too.
Yeah, just quick. We are basically just a small but very focused group on everything policy related.
Okay.
Kubernetes, and we have this weekly working group meeting around the time.
Mm-hmm.
And basically, we are gathering as much as possible that people are doing things that are related to policy in Kubernetes, and we track these items, and we also invite those authors to come to the meeting to discuss. For example, Torren was one of the frequent, and Erica and others are working on the scheduling policy.
Mm-hmm.
There's a Google team working on the security profile, which also involves policy. And there are others like topology awareness. There's like metadata policy and a couple of others. So yeah, we are by definition, the working group in Kubernetes are like cross-sig, with a theme, but cross-sig. So
how is it different from SIGAuth?
Well, SIGAuth only focus on the security or admission aspect.
Okay.
But for policy in general, you're gonna touch many things.
Yeah.
Like I said, like scheduling, which might have nothing to do with or include, admission authorization.
That's great that there's a focus area and complete focus area on policy. Actually, I was not familiar with this group until Ximpeng tweeted me. And so I actually gave my demo on the SIGAuth meeting.
Yeah, I saw that.
Okay, same kind of demo. But so this is great. So I mean, I think this is the place where you would get the most amount of feedback, and
yeah, hopefully.
Yeah. So I mean, I would do you know of any other projects that are solving similar problem, or like?
The only thing we know of is the SAFE working group for the CNCF. So a working group in the larger organization, which encompasses OPA, itself, and Istio, and Notary, and Tough, and lots of other projects.
So all of these projects kind of span very critical pieces of this problem, but none of them actually solve the problem for them.
I don't think anyone wants to own it because it's very large, broad, but
Yeah, but the
boring.
customers want it. That's the thing.
Yeah.
Yes.
So that's the important thing that drives me, right? So this came out of like, basically as me and one of the other folks in my team basically brainstorming and in thinking how talking to customers, and then figuring out what to do, and then kind of did so that we can have a language to kind of describe. And then I found about OPA and said, oh wow, this is great, but then it misses a lot of the other things.
Yeah.
So yeah, I think we are on a journey here, which basically
Yeah, absolutely.
it's nice to have a working group to discuss and
Yeah.
get feedback. And,
Yeah. Well, Kubernetes wise is just you guys and us. So
I see.
to
Okay.
work. Yeah.
I'll also invite other people to this working group who have contacted me who probably don't know about this working group, and
Cool.
they have
Yeah.
they're also
There's
working.
a Slack channel and information. You can find the information on the Kubernetes community.
Okay.
There's a on the SIG list markdown file.
Are you folks planning to come for the Seattle KubeConf?
I will be there, yes.
Yeah, and
Okay.
me too.
Okay, great. Yeah,
Yeah.
I'll see. I may have family engagement. If I kind of get some time, I'll stop by as well.
Cool.
I'm in Seattle, so
Cool.
cool. Thank you so much.
Okay, thank you,
really
and happy Thanksgiving.
Oh, you guys too.
Thanks.
Yeah.
Talk with you next week.
Yeah, have a giant turkey.
All right. Thank you. Bye.
Okay,
Bye-bye.
bye-bye.